Welcome back, Earth Science students, to week number 2 of online learning. I hope that week 1 went about as well as it probably could have, given the circumstances and everything, and this being all new to you. Okay, remember again, if you have questions, please reach out to me. As we get adjusted to all this, I hope it goes smoother and smoother each week, and that I can help you out as much as I possibly can. Couple things before we get started. Okay, some things I've been seeing. Make sure that you are uploading your assignments to Teams and not just emailing or sharing them with me. Okay, I don't want my inbox full of assignments. Instead, I need you to attach those to the assignments in Teams so I can just grade them right on there and we can just be done that way. Okay, because if I have all 70 of my students all emailing me separate assignments, then my inbox is going to get completely flooded and I won't know what's what. Secondly, I've been getting a lot of questions about where videos are posted. Okay, videos will always be posted in the different channels according to the date. So for example, this video is going to be posted in the March 30th, 2020 channel. Because that's when I released it, and it's for the content for the next 3 days. Okay, so every grading period, or however you want to say it, I will be unlocking a new channel based on its date. So for example, the very first one I did was 323. The next one I did was 326. This one is going to be 330, and so on and so forth. So the videos will always be in those. Now, with that being said, the assignments are all going to be under general because Teams won't let me do assignments in any other channel other than general. So instead of going to general first, make sure that you go to the date channel first, watch the video, and then you can do the assignments. Okay. A lot of questions like this can be answered in my office hours, and I can literally show you my screen and tell you where to go. As of right now, I've only had 3 total people in all of my classes show up to any office hours. Okay, so that means last Wednesday, Thursday, and Friday, I had office hours for an hour each day, and only 3 people total showed up. Okay, maybe that means you don't need help. Maybe those times don't work for you. But either way, if you need quick answers, those are the times to show up. I think somebody showed up in one of my office hours, and we literally finished his assignments in about 20 minutes, and then he went on his day. He didn't have to do anything for like the next 2 days science related. Okay, that's definitely a possibility. I can help you guys with those things. I did get some things from Mr. Jones on how grading is going to be. Okay, so grading we're going to keep as is, as we would normally do. Okay, so you're going to start seeing those grades from Teams start carrying over to Infinite Campus. As of right now, usually I did binder checks. Instead of binder checks, I'm going to use the video checks, like the forms that you guys fill out, as those binder checks. So that'll be, I think, 5% of your grade or 10% of your grade. I can't remember the breakdown right now off the top of my head, but it's going to be the same weight as our binder checks were. Okay. That being said, some of you, I could tell, took the video check before you watched the video. Do not do that. The video check is literally a check to make sure that you watched the video. I ask questions directly from what I say in the video. Okay. And so, for example, like the last video on water properties, for some reason I only have like 10 views and only 1 like, by the way, so, but whatever, I guess it's not that good. But either way, 10 views is not enough because obviously I have, I think 30 something earth science students. Okay, so I should have at least 30 views. Okay, so make sure that you are watching those videos. That's how you guys are getting your notes. On top of that, people have been asking, do I need to take notes? Guys, here's the reality of the situation. I cannot force you to take notes. I'm not right there. I'm not with you to make you do it. I can tell you, however, if you take notes, you will be able to refer back to those when you're doing the video checks, when you're doing your assignments, when we do quizzes. Okay, all those things are beneficial. It's a lot more beneficial than referring back to a 10-minute video where you don't know where and when I said certain things. Okay, so I highly recommend taking notes. Okay, but let's get on with the actual lesson today. We're going to be talking about weathering, erosion, and deposition. All right, so we have some definitions that we need to get across right away. First being weathering. Okay, weathering is the breaking down of rock either physically or chemically. Okay, so weathering is the actual breakdown of rock. Okay, now we have erosion. This is when after the breakdown of the rock, the moving away of that rock. Okay, so when something erodes away, it's the rock moving. Okay, so make sure there's a big misconception that these two things are the same. Okay, but make sure weathering is the actual breakdown. Erosion is the carrying away of that broken down rock. Okay, the three forces that do this are both water, wind, and ice. And notice that we talked about water in our last little block of information for this reason. Okay, so that we can get information about how erosion works with water. Okay, last is deposition. Okay, this is where the eroded rock ends up somewhere else. Okay, so you take the erosion, it carries rock. Deposition is where it ends up. So it drops the eroded rock somewhere else. Okay. So this is kind of an interesting graphic about how this all works. Okay, so if you imagine up here, we get some kind of rain or wind or ice breaking up rock. And basically what then happens is that once the broken material is broken up, okay, it starts to erode away. Okay, the rocks start traveling, and the deposition is where it ends up. Okay, so if you imagine all the sediment down here, okay, started way at the top of this mountain, and it traveled with the rivers and eventually ended up here. So that's all in one cycle of weathering, eroding away, and then depositing at the bottom. Notice that the root word of this word is deposit because that's where it ends up. All right, so there's two types of weathering because that's what we're going to talk about first. Okay, the first type is called mechanical weathering. So in a previous slide, I talked about whether it's physical or chemical. Mechanical is the physical part. Okay, this is the process of breaking up big rocks into smaller ones using physical force. Okay, physical force. Chemical weathering is the process of breaking up big rocks into smaller ones using chemical reactions. So there's some kind of reaction between the water and the rock or certain things and the rock, and there's some kind of dissolving or that sort of thing that's taking place to cause that kind of weathering. Okay, we're going to discuss both in the next 3 days. All right, so both of them have a bunch of different types of things that can happen. We're going to talk about mechanical weathering first, and you guys are going to do a little exploration. I'm going to have a separate video for mechanical weathering only. And so let's look at mechanical weathering is going to be, make sure you write all these down: frost wedging, exfoliation, thermal compression and contraction, crystal growth, abrasion, and tree roots. Okay, and then chemical weathering, dissolution, oxidation, and hydrolysis are all methods of chemical weathering. Okay, so what I would do personally is pause the video, okay, or get out of this video, and I would go over to the mechanical weathering, and then once you do that exploration, then you can come back to chemical weathering. Okay, now I'm going to continue on with chemical weathering, but that's just what I would recommend. Okay, so chemical weathering. Dissolution first. Dissolution, minerals dissolving in water. Okay, so when things dissolve, that's a chemical weathering application. Okay, so there's no real chemical change in this. H2O remains as water, but it's just used to dissolve things, kind of like dissolving salt or something like that. Okay, limestone dissolves to form caves. Okay, so we already talked about that when we talked about water. Obviously, the limestone is getting eroded away, so the water is breaking it down first, and that's again chemical weathering, and eventually it gets eroded away. Okay, another example, like I said, is salt dissolving in water. Anything where something dissolves is going to be dissolution. Next is hydrolysis. Okay, so hydrogen ions in the water dissociate and attack minerals in rocks. Okay, so the example of this is hard water. So if you've ever had something called like H3O, if you need, I don't know if any of you have water softeners in your house, but if you do, that means that you probably live somewhere where there's hard water, and it actually interacts with your body differently, and it can actually cause skin abrasions and stuff like that. It's just, you'd much rather have soft water than hard water. I know many of you may not have heard of that term before, but if you need to, look it up. But yeah, hard water is not very good for our purposes, for our body to use them. Okay, so in this one, chemical changes do exist. H2 separates to form new products. Okay, you can form H3O with hard water and that sort of thing. And that's all a process of hydrolysis. Always back to hydrolysis. Okay, and the last one is oxidation. Minerals react with oxygen. Okay, so this is the obvious one, the formation of rust. You know that if you leave certain things made of iron out in the rain, they're going to oxidize and form rust. Okay, so those are the three different types of chemical weathering. All right, so what we need to do is connect water that we learned about its properties last time to weathering now. Okay, and here's the connections. So we have all these different mechanical weathering processes, and they all occur because of all the properties of water. So for example, the fact that water has a high specific heat, that with that comes the accompaniment of thermal expansion and contraction of water, which causes that kind of weathering. Okay, the next one, universal solvent, okay, leads to why we have crystal growth as a mechanical weathering property. Okay, cohesion and adhesion is why water can be abrasive. Okay, so the abrasion mechanical weathering, literally just the breaking down of rock because of the cohesiveness of water. And lastly, we have density, and that leads to frost wedging. Okay, again, if you haven't gone through the mechanical weathering exploration, hey, you need to watch that video as well, where I take you through exactly what each of these are. Okay, and then the chemical weathering part, notice that all of them have to do with the fact that water is a universal solvent, meaning that it dissolves things pretty easily, or most things pretty easily.